Welcome to an interactive course designed for everyone who is working in the field of die casting and would like to work in Nadca 207 mode. If you do not know what Nadca 207 is, go through the whole course and you will learn everything important. This interactive course is split into several sections: General Introduction to Nadca 207, Material Selection and Testing, Design and Manufacturing of Dies, Heat Treatment, and AM Technologies in High-Pressure Die Casting. Last section is dedicated to the complaints and liability for defects. Each section also includes knowledge tests, which should enable better acquisition of basic principles and at the same time improve the knowledge of all levels of staff on this issue. There are few areas of mechanical engineering where a precise definition of tool manufacturing processes can be found and applied. Such a manual exists for the production of die casting dies and is published under the name Nadca 207, now in version 2025. It is a set of recommendations developed by the North American Die Casting Association for its needs and for its members. Not only the world's leading steel suppliers, such as Swiss Steel International, Udahome, Bowler, Kind & Company, Dido Steel, but also experts in heat treatment, for example, Body Coat North America or material testing. Especially Element Material Technology participated in its creation. Users also contributed to the specification, but most manufacturers of car engines, such as General Motors Powertrain or Ford Motor Company in the United States. This created a comprehensive set of recommendations for material selection, testing, heat treatment, and possible welding, aimed at achieving maximum lifetime of dies in terms of thermal fatigue. Although the specification does not address catastrophic tool failure, many recommendations can be applied to this type of tool damage. Nadca 207 specification was created only as a recommendation for tool manufacturers or for pressure foundries. In 2015, the Automotive Industry Association AIAG issued its CQI 27 guideline named Special Process Casting System Assessment. In Table H, intended for high-pressure die casting plants, is clearly specified that those who supply castings to the automotive industry are obliged to ensure that the design and manufacture of die casting tools is carried out according to specification Nadca 207. This changes the situation significantly, as it is no longer a free rule, but a mandatory. The driving force behind the creation of this standard was the increase in the service life of die casting dies for engine blocks at General Motors Powertrain and Ford Motor Company in the United States. It reached an average number of pieces of around 30,000 with very uneven results. But the requirement was to go with a service life of over 100,000 pieces per die. Given that the cost of one tool of this type can exceed 400,000 euros, then the emphasis on increasing the life is completely relevant. A new situation in the technology of die casting, known today also under the abbreviation HPDC, high-pressure die casting, is brought by Elon Musk and his Tesla's revolutionary change to the concept of car production in the gigafactory. The term giga casting is born when the existing several hundred parts of a car are replaced by several castings, produced on giga presses with a clamping force of up to 16,000 tons. The size of the die for die casting is growing significantly, as is its price. For example, the moving part of the die for the rear part of a Tesla car weighs 70 tons, while the fixed part weighs 40 tons. And what is the price of the tool? It is already climbing to the level of $4 million. The lifetime of the die will therefore directly affect not only the number of cars produced in this way, but also the economics of car production. That is why there will be an increasing emphasis on the stability of the technology for quenching large inserts in a gas stream weighing 1 ton or more. And so far, no one has come up with anything better than the procedures according to Nadca 207. First of all, it was necessary to define which properties affect this service life. It is known that the surface of a mold during die casting is subjected to alternating cyclic stress with regular alternation of the tensile and compressive components. During the actual injection of liquid metal, the surface is subjected to compressive stress. The moment the product is removed from the mold, the surface cools down. At this stage, the surface is subjected to tensile stress, which is critical for crack formation. It then depends on the properties of the mold material how many of these alternating cycles can be realized until a network crack occurs due to thermal fatigue. During each cycle, a certain elastic stress is induced in the surface of the material until the plasticity of the material is exhausted. This accumulation of stresses leads to the formation of cracks from thermal fatigue. The question is how to measure the properties of the mold material and how to evaluate them from the point of view of increased resistance to cracking. By applying a systematic examination of the material properties of steels for hot work, it was found that there is a significant correlation between the values of impact strength and the number of cracks from thermal fatigue. The higher the impact strength values, the lower the tendency to form thermal fatigue cracks, and vice versa. The lower the impact strength values are achieved, the greater the tendency for thermal fatigue cracks to form. This is one of the most significant findings of this research. Therefore, if we deal with the specification of steel properties that increase the impact strength, then we will achieve a longer tool life. The issue of impact strength of steels for hot work can be divided into two basic groups. First, it is the input material and its properties. Second, it is heat treatment. The selection and purchase of input material is the most important part of the whole process. It has its own rules, which will be described below, and requires highly specialized knowledge. Since the quality of the input material is significantly dependent on the method of steel production, it is necessary to have knowledge of which types of steels can be used for this application and which must be completely ruled out. Nadca 207 solves this by precisely specifying the steels that can enter the die casting insert manufacturing process. And all other steels are then excluded from this process. Heat treatment is another important step in the production of die casting tools and has its own rules, which must not only be observed, but also controlled. However, it must be taken into account that the aim of the heat treatment is to maintain the purchased properties of the material. No heat treatment can improve them, but it can make them significantly worse. It is therefore important to have a reliable supplier with highly specialized knowledge for this operation, but at the same time, it is necessary to control this supplier. A condition for solving tool life is strict testing of the input material and verification of the material after heat treatment. Testing is usually carried out through impact tests, and it is precisely specified what values the selected material should achieve before entering production, and what values should be achieved after heat treatment. If the test results are within the recommended range, then the life of the mold should correspond to this. A simplified assessment is also possible using metallographic inspection. Part of the Nadca 207 regulation are metallographic maps of permissible and inadmissible structures for both the input material and the material after hardening. Although it is a method that does not evaluate material properties directly, it is a method of comparison, which makes it possible to exclude extreme material excesses. The entire Nadca 207 process is based on two essential control points. The first is the incoming inspection of the material, verifying that the material with the ordered properties was actually delivered. Only if the input tests meet the values according to Nadca 207 can this material be released for tool production. If the tests do not pass, then the material should be immediately replaced by the steel supplier with a new material with properties according to the specification. The second essential control point is checking the correctness of the heat treatment. This again consists in the assessment of impact strength. If the values are satisfactory, the insert is released to be finished and built into the mold. If the values after the heat treatment do not satisfy, then the heat treatment plant must re-anneal the material to a soft condition and reharden. If even in this case the results are not in accordance with Nadca 207, and at the same time the input tests were satisfactory, then the heat treatment supplier is not entitled to reimbursement of the costs of the hardening process, but at the same time should also reimburse damages arising either from the reduced life of the tool and/or to the production process of a new insert. This is absolutely key. Nadca 207 is therefore not only a specification of material and heat treatment procedures, it is also a guide to resolving commercial disputes that occur during the production and use of die-casting dies. The topic of these disputes will be discussed in more detail in Chapter 6, Complaints and Liability for Defects. The introduction into Nadca 207 course is over. It includes my many years of experience and practice. However, the issues can be very complex and extensive and may not exactly match your experience. If you have any comments or suggestions for improving the course, please send them to the contact listed. My goal is for the courses to provide essential information for heat treatment employees at all levels so that they can continuously improve. The level of content is therefore adapted to allow both existing employees and new employees who do not have knowledge in the field to take part in this course. Based on these comments, I will improve and expand the courses so that they are a real benefit to everyone. As you have probably noticed, the course was not voiced by me, but by the great speech generator 11 Labs. Thanks to him, my English will also be understandable. So thank you also to Bill and his voice for his contribution to the field of heat treatment. What you saw as a video on YouTube is just a picture of what is created in Adobe Captivate as an e-learning course. It is available on my website, jstconsultancy.cz. You can access it for €20 for 1 week, €40 for 1 month, or €60 for 1 year. The course is created in HTML5 format. However, it can also be exported to SCORM 1.2 format, which stands for Shareable Content Object Reference Model. Other formats are possible for different LMS systems. You can order this form at my email address, and you will receive the complete course in HTML5 code and a perpetual license for €200 per course. The compressed zip file will be 50 to 200 megabytes in size, depending on the content of the course. You can then install this file in your corporate cloud or in Moodle LMS 5.0, on SharePoint or in the HR module of your ERP system, such as SAP, which can communicate with a learning management system, LMS, that meets the LMS specification. In this case, you will be able to prepare a training plan for each employee, including an evaluation of its implementation and success rate. Each course contains a test with many questions, and the output is a certificate of successful completion of the course. You can archive these certificates and use them for employee motivational rewards. The advantages of e-learning are obvious. The employee does not have to go anywhere. They can complete the course anywhere, on a computer, tablet, or even a phone, at work, on vacation, or even at home. And you will be sure that they have the necessary knowledge to understand what is happening in the heat treatment operation. I do not know of any disadvantages, so I just hope that these courses will serve you and be useful to you. And what is my vision for the future? You can see this in this process map. So far, 16 have been created in Czech and English, and I will gradually add new ones, depending on their importance in the life of the heat treatment operation. I don't know if the courses are perfect, but I'm sure it's a promising form of education that we shouldn't ignore.